Okay, so this is going to be free response set number 3. So we'll go ahead and get started. So this is going to be a velocity and acceleration question. So part A, it gives you the velocity graph, and it says for part A, you want to find Karen's her acceleration time at t is equal to 7.5. Okay, so A of 7.5. So acceleration is going to be the slope of the velocity graph. So we're going to go with 7.5. It's in here. In this little region right here, you're going to just find the slope of the line. So it's going to be down 0.1 and over 1. So it's going to be a negative 0.1. And indicate units of measure. It's going to be miles per minute per minute. Because your velocity is given in miles per minute, and so your acceleration, you're going to add on another time unit. Part B, it says using correct units, explain the meaning of the integral from 0 to 12 of the absolute value of the velocity. So that's going to be the total distance traveled from t is equal to 0 to t is equal to 12. Okay, and then I want to find the value of that. So all the absolute value means is we're going to make it positive when we go to find the area of this. Now, it's important that you make sure that you find the areas, and these are in tenths, okay? So this is 2 by 0.2. So area of a triangle is 1/2 the base times the height. So that comes out to be 0.2. This is the same shape, but it is just negative, so we're going to make it positive, so it comes out to be 0.2. I did a triangle right here and made that 0.15 whenever we go and do the area of that. So 1 times 0.3 and divide that by 2 is 0.15. I did a huge rectangle. So we did this one. I did a rectangle from here all the way up here. Okay. So I got that was 1. I got the mini triangle up here. So it's going to be 1.1, divide that by 2 is 0.05. And then I have a square that's going to be 1 by 0.1. So it's 0.1. Add all those together. And she travels 1.8 miles. Okay. Part C, it says, shortly after leaving home, Karen realizes she left her calculus homework at home. She returns back to get it. At what time does she turn around to go back home? Remember, we can tell where a particle changes direction when the velocity is equal to 0. Okay, so our velocity is equal to 0 at t is equal to 2, because she's going to change direction. Goes from positive to negative velocity. Okay? Part D, it says Larry also rides his bicycle along a straight road from home to school in 12 minutes. His velocity is modeled by the function pi over 15 sine of pi over 12t. And we want to determine who lives closer. So the way we can tell this is by the displacement, okay? So Karen's displacement, so she turns around here and then she starts back on her journey. Okay, so this whole area right here came out to be 1.4 miles. We can determine Larry's displacement by integrating this in our calculator. Make sure you're in radians. Okay, so we're going to put that in y equals. Sine of pi over 12 x. Okay, we're going to integrate that math 9 vars. We're going to integrate it from t is equal to 0 to t is equal to 12. Okay, so he lives 1.6 miles away. So it says who lives closer to school? So Karen lives closer to the school. And that's how we answer that question. Okay, next part of the questions. Okay, so it says that we have some people entering an auditorium, okay, for a rock concert at a rate given by R of t from 0 to 2. No one is in the auditorium at t is equal to 0 when the doors open. The doors close and the concert begins at t is equal to 2. So they shut the doors and everyone's inside. Okay? So how do I find the amount of people given a rate? I integrate. So if I want to know how many people are in the auditorium when the concert begins, I'm going to integrate from 0 to 2 of r of t dt. This is a calculator question. So we're going to put that function in y equals 1380 x squared minus 675 x to the third. We quit. We're going to math 9 bars y1 comma x comma 0 comma 2. And you should get 980 people. Okay, part B. Find the time when the rate at which the people enter the auditorium is a maximum. So the way we tell maxes and mins is by taking a derivative, okay? So if I want to know when the rate is a maximum, I'm going to take the derivative of this, okay? So when I get the derivative of that, I get 2760 t minus 2025 t squared. And I want to know where it's a maximum, so I have to find my critical points, okay? So we are going to put that in y equals. Okay. And we are going to graph it. Okay. So, and we're going from t is equal to 0 to 1. Let's go and change our 0 to 2, sorry. 0 to 2. Okay, so we got to find that 0. Okay, I found that 0, and it comes out to be t is equal to 1.3629. Okay, and it goes from positive to negative, so it's a local max. Now, when it talks about number of people or number of tickets sold being a maximum or a minimum, we have to consider our endpoints also. So we're going to say R of 0, R of 1.3629, and then R of 2. Okay, now we're going to put these in our calculator, and y equals, so R was 1380 x squared minus 675 x cubed. Go to our table, and we're going to go 0, 1.3629, and then 2. Okay, so we get 0, 854.53. And then 120. 528. Actually, that's 528. So this would be your absolute max. Okay? And this would be your absolute min. Part C. It says the total wait time for people in the auditorium is found by adding the time each person waits, starting at the time that the person enters the auditorium and ending when the concert begins. The function w of t is your waiting time. So w prime of t is equal to 2 minus t times r of t. We want to find the value of w of 2 minus w of 1. Okay, the total wait time for those entering after t is equal to 1. Okay, so what's important about this question is you recognize that this is going to be a first FTC. Okay, so the integral of w prime of t is equal to w of 2 minus w of 1. Okay, so we're going to integrate that function in our calculator. Okay, so I'm just going to insert some parentheses. Like that. And I'm going to do math 9. I'm going to integrate from 1 to 2. So I get 387.5, and we're going to be in hours. Okay. Okay, so that's the total wait time for every single person that enters the auditorium, not per person, because that just doesn't make any sort of sense. Okay, part D. It says on average, keyword, how long does a person wait in the auditorium for the concert to begin? Okay, so we need to consider those that enter and exit. Okay, so your wait time function, your total wait time, is what we just found. Okay, and so we're gonna keep that in y equals math 9 vars y1 comma x comma 0 comma 2, and you get 760 hours, and there's 980 people in the auditorium. Okay, so we're going to divide those two numbers. We get 760 divided by 980, and you get 0.7755. Hours per people, hours per person. Okay, next problem. Go on to something a little bit less complicated. Okay, so it says estimate f prime of 4. So on this, when we have a table, we locate where 4 is. So we estimate, we're just going to find the slope. Negative 2 minus 4 over 5 minus 3. So we get negative 6 over 2, which is equal to a negative 3. Okay, part B, it says I want to evaluate this integral. So the integral from 2 to 13 of 3 minus 5 f prime of x dx. So when I find this integral, I'm going to split it up into two separate integrals. Okay, so the integral of 3 dx is just 3x. So I plug that in, I get 39 minus 6, which should come out to be 33. Okay, now remember, the integral of f prime of x is equal to f of 13 minus f of 2. So I'm just going to read from my table. F of 13 is 6, f of 2 is 1. Okay, so 33 minus 25 should come out to be 8. Okay, I like this type of question. I feel like that this would be on the 2020 free response, something dealing with a table, and first FTC, always a good question. C, it says use a left Riemann sum to approximate the integral from 2 to 13. So left Riemann sum, so we make our intervals 1, 2, 3, and 5. Okay, so we're going to use the left point. So this is going to be 1 times 1 plus 2 times 4 plus 3 times a negative 2 plus 5 times 3. So we get 1 plus 8 minus 6 plus 15. So 9 minus 6 is going to be 3. 3 plus 15 is 18. Okay, so it says, suppose that f prime of 5 is equal to 3, and the second derivative is equal to, is a negative number. It says Use the line tangent to the graph at x is equal to 5 to show that f of 7 is less than 4, less than or equal to 4, okay? So, for part D, we need to know that f of 5 is equal to negative 2, okay? So f of 5 is equal to negative 2. That comes from our table up there. F prime of 5 is equal to 3. So the equation of the tangent line is y minus a negative 2, so that turns into a plus 3 times x minus 5. Now, I'm estimating this at 7, okay? It says use the line tangent at x is equal to 5 to show that f of 7. So I'm looking for the y value at 7. So 7 minus 5 is 2. 2 times 3 is 6. 6 minus 2 gives you the 4. So that portion's true. It says use the secant line. So the secant line is just the equation of a regular line. So we're going to use these 2 points right here. So we're going to do f of 8 minus f of 5 all over 8 minus 5. So 3 minus a negative 2 all over 3. So your slope comes out to be 5/3. And your secant line is y minus, you can use either point. I'm going to use the one that has the positives. So y minus 3 is equal to 5/3 times x minus 8. And I'm going to plug in a 7. So this is y is equal to 3 plus a negative 5/3, which comes out to be 4/3. Now, it's important to see that these equal to signs, less than equal to signs, greater than equal to signs, they're equal to. So the actual value can be equal to it. This statement's important. Okay, so if it's concave down, and I'm dealing with something over here, okay? Concave down, your tangent line, no matter which way you're going, is going to be above the graph. So it's going to be an overestimate usually, okay? So just keep that in mind as we go through these free response questions to make sure we hold on to that stuff. Okay, number 4 is a solids of revolution question. Okay, so you got y is equal to 2x is this line right here. And then you have the graph y is equal to x squared down here. Okay, so it says you want to find the area of R. We already have our intersection points. So we're going to do integral of top curve minus bottom curve. Your top curve's 2x, bottom curve's x squared, dx. We're going to integrate this by hand. Okay, so we get 4 minus 4/3, which is going to be 4/3. Okay, we did around the world. 4 times 3 is 12. 12 minus 4 is 4. Part B. I don't know if we've worked one like this, so it's good to work this. The region R is the base of a solid. For the solid at each x, the cross-section perpendicular has the formula a of x is equal to sine of pi over 2x. Find the volume of the solid. Okay, so the integral of area gives you volume. Okay, so we should be able to integrate that by hand using u sub. Your u is pi over 2x. Your du is pi over 2 dx. We don't have the pi over 2 on the outside, so we got to get rid of it. Okay. So the integral of sine is a negative cosine. Okay, so we're going to plug in our 2. So cosine of pi minus negative 2 over pi cosine of 0. Now, cosine of pi is a negative 1. So this becomes 2 over pi. Minus minus turns into a plus plus. So it's 4 over pi. Okay, the last little question says that we're going to do cross sections, but they're perpendicular to the y-axis. So if I'm perpendicular to the y-axis, I have to have x equals. So I'm going to solve each one of these equations for x equals. Okay, so I get x is equal to y over 2, and x is equal to square root of y. We're in the first quadrant, so it's going to be positive. Okay? Now, when we do any sort of axis of rotation or anything like that, we draw our ladder. Okay? And we're going to do right curve minus left curve. Now, with squares, the area of a square is side squared. We need y limits, so 0 to 4. And we're going to do right curve minus left curve, so it should just be square root of y minus y over 2 squared dy. Okay, and it just says set it up. Okay, next question. This is super important that you understand how to interpret this type of graph. Okay, so we're given the derivative graph. Okay, so for part A, it says for x goes to -4 to 4, find all the values of x at which the graph of f has an inflection point. Okay, we know that inflection points occur at the maximums and the minimums on f prime of x. So that's how we have to justify that. So we said inflection points at maxes and mins or hills and valleys, if you want to say it in your head. So there we go. Part B, it says find f of -4. Okay, so -4 is in this branch right here. So we're going to integrate from -4 to 0 of f prime of x dx. And that gives you f of 0 minus f of -4. Now, f of 0 is given to you as 5 up there. So the way we find the value of this integral is by geometry. Okay, so we did one of these last week. Okay, so we got a rectangle. So the area of this rectangle is going to be 4 by 2, which is 8. Okay, and then we got a semicircle. So area of a semicircle is pi over 2. R squared, your radius is going to be 2. So the area under the curve, which we're looking for, is going to be 8 minus 2 pi. So 8 minus 2 pi is equal to f of 0 is 5, and f of -4 is what I'm looking for. So solving for f of -4, you should get 2 pi minus 3. Okay. Now, for the second portion, f of 4 is going to live in this branch right over here. So we're going to integrate from 0 to 4 of 5e to the -1/3 x minus 3 dx. And that's going to be equal to f of 4 minus f of 0. Okay, so we got a u sub here. Your u is a -1/3 x. Your du is going to be a -1/3 dx. We have to get rid of the 1/3. So we multiply by 3. So when I integrate this, I get -15e to the -1/3 x minus 3x. Okay, and I'm going to plug in. My 4 and my 0. E to the 0 is going to be 1. And then plug in a 0, you get 0. Okay, so that comes out to be So 3 minus 15 e to the negative 4/3, and that's equal to 5 f of 4 minus 5. Okay, so the answer to this portion, f of 4 should come out to be 8 minus 15 over e to the 4/3 power. Or you can write it as e to the negative 4/3 power. Okay, so we want to, in part C, it says you want to find where f has an absolute max, okay? So your critical points are going to be at x is equal to -2 and x is equal to, it says it crosses the x-axis at 3 natural log of 5/3, okay? So your critical points are x is equal to -2 and x is equal to 3 natural log of 5/3. Okay, so we would only have an absolute max in this case here or at the endpoints. Okay, so we don't need to really consider the -2. Okay, so the absolute max is actually going to occur at x is equal to 3 natural log of 5/3 because it goes from positive to negative. And there's no real way to get the area like an actual number from this graph. So that's a good enough justification. It's going to have the most area. So like from here, if I start at this point right here, the area would be 0. If I go to here, oh, that's a little bit of area. Okay, from here to here, that's going to be the most area that's positive. Okay, so that's going to be your absolute max. If I go all the way to this endpoint, you have some negative area that we're going to be subtracting out. Okay. Okay, so that's it for AB. And if you want to work AB, part C of this, feel free to. It's just good differential equations practice. Okay, part A. It says we're going to use Euler's method using 2 steps to approximate f of 0. Okay, so my h is going to be 0.5. Okay, because I'm going to be going up by 0.5s. So Euler's method is y1 equals y0 plus h times f of 1. Okay, so y1 is equal to your initial y value is 2, your step size is 0.5, and f of 1. So I'm going to plug in, f of 0, I don't know why I wrote that. Okay, so we're going to plug in our initial point into our derivative. Okay, so when I plug that in, -1 squared is 1, so 6 minus 2 is 4. Okay, so when I plug that in, I get 4. So this leaves me at the point -0.54. Now I'm going to repeat the process again. Okay, we've worked enough of these problems that you should be pretty good at these by now. Using this y value, h stays the same. Okay, so we get 4 plus, it should be positive 1/2, positive 1/2, when we do our derivative. So to get your derivative, you're going to plug this point in up here. So you should get 6 times -1/2 squared minus -1/2 squared times 4. Okay. This comes out to be 6/4, which is 3/2. And then this comes out to be 1, because 1/2 squared is 1. Okay, so 0.5. So you get 0.5 times 0.5 is 1/4. So this comes out to be 17/4. I kind of think this was a calculator portion of the question, so I mean, it's not overly difficult to do without a calculator, so just be able to do them both ways. Okay, part B, it says I want to write a second degree Taylor polynomial for f. Okay, so we do at x is equal to 1. So f of negative 1 is 2. My first derivative I found right here. So your first derivative when I plug in that point was 4 times x minus 1. So remember, when it's not centered about 0, I have to do my x minus c. And it says the second derivative is negative 12 over 2 factorial times x minus 1 squared. Now you can leave it like that or you can simplify it. This is easy to simplify, so. Sorry, it's at negative 1. I messed this up twice. These are pluses. X minus a negative 1, sorry. Second time I did that. Sorry, guys. Okay, third part of this says you want to find the particular solution to the differential equation. So we should be really good at these now. Okay, so we're going to solve this differential equation up there. Okay, so from here, they have an x squared in common, so I'm going to factor that out. And I'm going to move my y terms to one side, my x terms to the other, and I'm going to integrate. When I integrate this, this is a u sub. Your u is going to be 6 minus y. My du is going to be a negative dy. Don't forget that. You're bad about forgetting this. So this becomes a negative integral of du over u, which goes to natural log. Okay, negative natural log of 6 minus y is equal to 1/3 x cubed plus c. Now I'm going to use my initial condition that gets me up here. Okay, so I get negative natural log of 6 minus 2 is 4. And I'm going to plug in a negative 1 cubed, so it's a negative 1/3 plus c. So if I was to solve for c, c comes out to be 1/3 minus natural log of 4. Okay, now we got to solve for y. So negative natural log absolute value of 6 minus y is equal to 1/3 x cubed plus 1/3 minus natural log of 4. I'm going to divide everything through by a negative sign, okay? Okay, now to get rid of the natural log, I'm going to e both sides. Okay, this one's for Jerry for waking me up at 3 o'clock in the morning about this question. Okay, so e and natural log, those will cancel and it becomes 4 out in the front. Okay, when we add exponents, we're multiplying. Okay, and then to solve for y, we're going to drop the absolute values. We're going to put plus or minus. And then we have to determine which branch we're going to be in. So y comes out to be 6 plus or minus 4e to the negative 1/3 x cubed minus 1/3. Now our initial condition is 2. So if I was to plug in a negative 1 up here, I get 0. So this would have to be 6 minus 4. So I'm in the negative branch. And that is how we solve differential equations. Y'all should be really good at that by now. Okay, so I want to save this question for y'all because I thought it was a little bit tricky to work with. I actually had a little bit of trouble earlier today with it. Okay, so we're given a piecewise function. the function f defined above has the derivatives of all orders. Let g be the function defined by g of x is equal to 1 plus the integral from 0 to x of f of t. Okay, so it says write the first three non-zero terms in the general term of the Taylor series for x, for cosine x at 0. Okay, so I'm going to write small so I don't run out of room. Okay, so I'm going to say f of x is equal to cosine. When we do our Taylor series, we're going to take the first few derivatives. Derivative of cosine is a positive sign. Now it says you want the first three non-zero terms, so I stopped there because cosine of 0 is 1, sine of 0 is going to be 1. Okay, so when I go to do my terms, it's going to alternate. Like that. So your first three terms, when you go to do this, are going to be f of x is equal to, okay, so we're going to write the first term, 1. Skip that one. Go to the second term, minus 1 over 2 factorial x squared. Skip that one because multiplied by 0 plus 1 over 4 factorial x to the 4th. So it's 1 minus 1 half x squared plus 1 over 24 x to the 4th. Now, we need to do our general term, and this is where we struggle. Okay, so this is technically n is equal to 0, n is equal to 1, and n is equal to 2, regardless of what's up here. Okay, so my general term, it's going to alternate on the odd terms, okay? And my x is going to be raised to the 2n, okay? As we keep going out, because they're even powers. And I'm going to divide that by, I'm dividing it by whatever that exponent is, factorial. So 2n factorial. Okay, so that's my general term. So that's part A. Tricky, I know. Take a second and look at it again if you need to. Okay, part B. Wait. And then it says, use this series to write the first three non-zero terms in the general term of the Taylor series for f. So we just did the first part of this, okay? So we're plugging in right here. That's what we're taking all this right here and plugging in, okay? So, and this is where I got confused at. So it's going to be 1 minus 1 half x squared plus 1 over 24 x to the 4th minus 1 all over x squared. Okay? So we're taking that and we're dividing everything through by x squared. So 1's cancel. And you're left with negative 1 half x squared, negative 1 half x squared divided by x squared is 1 plus 1 over 24 x to the 4th divided by x squared is x squared. Now it says you want the first three non-zero terms, so we need to go out another term. Okay, so it'll be x to the, so this would be like x to the 6th, like that, if we were, following the pattern. So x to the 6th divided by x squared is x to the 4th. So it's negative. So it's x to the 4th over 6 factorial. And so when we go to do this, our pattern that we're following for our general term is going to be -1 to the n minus 1, or n plus 1, doesn't matter which one. This is n is equal to 0, n is equal to 1, and n is equal to 2. Our x is being raised to the 2n power, but our factorial is changing on bottom. So this is 2 factorial, this is 4 factorial, and this is 6 factorial, okay? So it's 2 more than the previous one. So it looks like that. This is a hard question. I mean, I thought it was super confusing to do. Okay, part B. It says use the Taylor series for f of about x is equal to 0 found in part A. So we're looking at this. And it wants to tell if you have a relative max or min at x is equal to 0. Okay, so f prime of 0, we don't have an odd term right here, so it's 0, the derivative is 0. Now, that makes sense because at a max or a min, your slope is 0. So, how do I tell if you have a max or a min? Well, this is going to be concave up because it's 1 over 24 divided, sorry. Okay, so the way I would do this is our second derivative tells us if it's concave up or concave down, divided by 4 factorial is equal to 1 over 24. Okay, so that's what we have. So if I was to solve for f double prime of 0, and it's obviously going to be a positive number, 4 prime is 24, so f prime of 0 is 1, which means it's concave up. So if something's concave up, that means it's a relative min. Okay, part C, it says write the 5th degree polynomial for g about x is equal to 0. Okay, so what I want to do is I want to integrate this, okay? So g of x is equal to 1 plus the integral from 0 to x of f of t dt. Okay, so I'm going to integrate these terms over here. So it's going to be 1 plus the integral of 1, oh crap, sorry. The integral of -1/2 is -1/2 x. The integral of this is going to be x cubed. So 1 over 72. I believe that's right. 24 times 3. 72, okay. And then I'm going to integrate this term right here. X to the 5th, okay, and you're going to get a really large number. Okay, 6 factorial is going to be 720 times 5 is 3,600. So you don't have to write these numbers out if you don't want to. And that is how we find our 5th degree Taylor polynomial. It's to the 5th degree. Remember, if you were to integrate this and it was to come out to be greater than the 5th degree, we only look at the terms below that. Okay, I understand that this was a long free response set, but hopefully this continues to get easier for you guys. Thanks, and hopefully you have a good night.